We're continuing with section 4.5, and this time we're looking at limits that are not 0 over 0 or infinity over infinity, but we can use some algebra to convert them to those the two limits of those two forms, and use L'Hopital rule. So first example is this limit, 1 over x minus cosecant x, and as x approaches 0 from the positive side. When you're doing this limit, what you realize is that the limit, the expression that you're taking limit of 1x over minus cosecant of x as x approaches 0 is 1 over 0 minus 1 over sine of x, which sine of 0, and it's infinity minus infinity. So the form is infinity minus infinity. Both of them are positive because x approaches 0 from positives from right, and also same thing for sine. And now I know that infinity minus infinity is not in my toolbox for L'Hopital rule. So what I do is I do a common denominator, and common denominator gives me sine of x minus x over x sine of x. Now if I, let's say, so limit as x approaches 0 from positive from the right side, that's the original limit, can be simplified into this limit. And this time around, it's not infinity minus infinity, because when I plug in 0, I get 0 minus 0 over 0 times 0, which is 0 over 0. So the form is right now. Form is 0 over 0. So I can do an LHR. And when I do the LHR, I end up with cosine of x minus x, and the minus 1, sorry, and the denominator is a product rule, so sine of x plus x cosine of x. Now if I plug in 0 again, and this time I'm going to get 1 minus 1 over 0 plus 0. So again, form 0 over 0 again. So I may want to do another LHR. And this time when I'm taking the derivative, cos derivative of cosine is negative sine of x, and derivative of sine of x is cosine of x. Derivative of this product is, first of all, a cosine of x, then minus x sine of x. Now if I plug in values, if I plug in 0, I get negative 0, and 1 plus 1 minus 0, so I'm going to get a 0. And so the limit of this limit was 0. So let's discuss another form that can be covered by L'Hopital rule, and that's 0 times infinity. So the beauty of 0 times infinity is that you can always write 0 times infinity as, let's say, the other way is 0 over is 0 times 1 over 0, and that makes it 0 over 0, or you can write it as 1 over infinity times 0. So one of these methods usually works on that. And so let's do this with examples. So basically you write it as either you write, this is a 0 times infinity form, so you write it as function that is 0 divided by 1 over the function that is that goes to infinity, and then you get an as 0 over 0, or the other way around, you write it as the function that goes to infinity divided by 1 over the function that goes to 0, and that's the infinity over infinity form. Which one should we choose? Whichever the derivative is easier to take. And so over here, when I see this is the form 0 times infinity, negative infinity, but in either case. And so I look at this. Do I like to put 1 over ln of x? No, I don't. And so I go with x. And so how do I go with that? I write it as ln of x stays. That's one that I don't want to do. And so, and I want to make x to be 1 over x, but 1 over x cannot stay in the top. It has to go in the bottom, because this, then it becomes reciprocal of the reciprocal, and it's in the right place. Now, let's take the derivative of this, and what do I get? I mean, let's do the L'Hopital rule for this and see what happens. And so the top becomes 1 over x, the bottom becomes 1 over x squared. Now let's simplify this, because if I continue doing L'Hopital, you will notice that you're not going to get anywhere. That's one of the cases that L'Hopital is not going to work. You have to simplify before doing anything else. And so simplifying here will give me x squared, negative x squared over x, which is negative x as x approaches 0 from right, and that's equal to 0. And so the answer to this is going to be 0. Now let's do another limit that is basically infinity is 0 times infinity. Here, form limit as x goes to x goes from the left side to pi half of x minus pi half tangent of x. So x pi half minus pi half is 0. Tangent of pi half, if you remember the tangent function, looks like this. And we're going from the negative, from the left side, so we're approaching a positive infinity. So 0 2 times form 0 times infinity. Now what do I do? Now I'm trying to see, is it easier to reciprocate x minus pi half, or easier to reciprocate tangent of x? Well, it seems like tangent of x can become cotangent of x. So I'm going to write down limit x as pi half. And if I'm reciprocating, I have to do it twice. So I'm taking it to the bottom. I get cotangent of x in the bottom. X minus pi half over cotangent of x. And then limit with LHR as x approaches pi half. Derivative of x minus pi half. Let's rewrite this. X minus pi half. Derivative of x minus pi half is just 1. Derivative of a cotangent is negative cosecant squared of x. And so now cosecant squared at pi half, cosecant squared is 1 over sine squared of pi half, and sine squared of pi half is 0. So I'm going to get an 1 over infinity, but that is a determinate form, and it's going to be also 0. So let's do an L'Hopital rule, and we get limit as x approaches pi half from the left. Limit, the derivative of top is 1. The derivative of the bottom is cosecant squared x. And then when I'm trying to plug in, I get 1 over minus cosecant squared pi half, which is cosecant is 1 over sine, so this is negative